All right, so today's chain rule was section 2.4. We're going to talk about the derivatives of bases that are not e. So what is a base that's not e, or an exponential that's not a base of e? We might have something maybe 3 to the x, where we see that the variables in the exponent, our base is just a number, just a constant, f of x. So we're going to find the derivative of that. So we have 4 rules that we're going to talk about, and hopefully we're going to make some connections between those exponential functions and logarithmic functions that we saw earlier within our chain rule. So here we have d dx, the derivative with respect to x of a to the x. And here a is going to be a constant. I guess I should have written that out there, but a is going to be just a constant, just a number. So maybe like the 3 to the x. So derivative of 3 to the x is going to equal the natural log of that constant times the function a to the x. So if you think about that, that looks very similar to e to the x, doesn't it? Remember, the derivative of e to the x gave us e to the x. And in this case, if you think about a as being your e, well, if I took and multiply this by the natural log of e, what do we know about the natural log of e? Ah, yes, it's 1, isn't it? So we just end up with an e to the x. So all we're really doing is bringing along the natural log of that constant. Same thing if here we take the derivative with respect to x of a to the u. Again, here maybe u is going to be a function. So just not a single variable. So in that case, we're taking the natural log of that constant again, a to the u, so the function stays the same, and then the derivative of the function, or the exponent, is going to come down and multiply to it. Also with your logs, so log base a of x, we're going to take 1 divided by the natural log of that constant, that base now, times x. Or just that value there, that x value. If we have going back up to this, think about it if we had the natural log. Remember, natural log is log base e of x. I'm going to go ahead and put that natural log in next there. So we have the natural log base e of x. If I think about that rule, I have 1 divided by the natural log of the base, which is going to be e, and then times the value there, so x. What do you know about the natural log of e? Well, that's 1 again. So we end up with 1 over x. So the derivative of natural log of x, which is 1 over x. So it works just the same as our natural logs did. What happens if we have the derivative of a log base a of u? Again, u should have written out, I guess, was a function. So here we take 1 divided by the natural log of the base times the function, the value there, and then times the derivative of that function that we're taking the log of. So again, think about it. Things to think about. Exponentials and logs are very close to e and the natural log derivatives. We just have to add in that natural log of a. When we have an exponential, the natural log of a goes to the top. And when we have logs, the natural log of a goes to the bottom. Hopefully you remember exponentials. They were all in the top. Logarithmic, we made a fraction. That natural log went to the bottom. All right. So how do we find the derivative of 5 to the x, or if we wanted 3 to the x up there? So how do I find the derivative there? Well, my f prime of x, we're going to take the natural log of the base, natural log of 5, and then to that we're going to multiply the function 5 to the x. And there you go. We're done. Simple as that. Easy peasy. All right, so derivative of f of x equals 5 to the 2x plus 3. So here, now our exponent isn't just a single variable. So how do we do that? Well, our first derivative then is going to be the natural log of that base, which is 5, times the function, 5 to the 2x plus 6, and then times the derivative of that base, which is going, or the exponent, sorry, which is going to be 2. And you could rewrite this maybe as 2 natural logs of 5 times 5 to the 2x plus 6. Now I will caution you, this is kind of where they get a little tricky. This 2, remember your rules for natural logs and logarithmics, that 2 could be written as the base. So we could see this as the natural log of 5 squared, or the natural log of 25 times 5 to the 2x plus 6. So you do want to be careful, especially multiple choice, that they could do that to you. I wouldn't do it if it's extended response. I would leave it probably up here, honestly. They'll probably ask you to do something with it, maybe find the value at a point or something. But I would leave it just like that up there and be done. Let's see, example 3, log base 7 of 3x minus 1. So can we find the first derivative? Well, hopefully we can. We have 1 over, again, we have the natural log of the base there, natural log of 7, and then times the function, 3x minus 1. Just like our natural logs, we have 1 over that. And then we're going to multiply by the derivative of this function, derivative of 3x minus 1, which is 3. So we end up with 3 over the natural log of 7 times 3x minus 1. And that's going to give us our derivative. There you go. Let's see, log base 4 of x minus 1 over x. So can we find the derivative of this? And hopefully, I do a lot of hoping, don't I? We can rewrite this as log base 4 of x minus 1, that quantity. And then we're dividing two things that we're taking the log of, so we can subtract log base 4 of x. So now can we find the derivative of these two pieces? And hopefully we can. Again, hopeful, hopeful, hopeful. So we have 1 over the natural log of 4 times the quantity x minus 1, then times the derivative of x minus 1, which is 1. And from that we're going to subtract 1 over the natural log of 4 times x. And if you want, times the derivative of the function, which is just going to be 1 over 1. And so there you go. You could clean this up a little bit, I suppose. 1 over, we got what, x minus 1 times the natural log of 4, minus 1 over x natural logs of 4. We could find a common denominator, which is going to be x times x minus 1 times the natural log of 4. So our numerator up here is going to get an x minus an x minus 1. So that gives us a simple 1 over x times x minus 1 times the natural log of 4. And that's something that you could do if you wish. It's kind of up to you on how far you want to take that. Let's see, I think I have one more example, and I do. Notice here we have f of x as being 3 log base 2 of x divided by x. So here we have a log within a fraction. Oh, how ugly. So here we actually have a quotient rule to begin off with. Our quotient rule tells us x and then derivative of 3 log base 2 of x. So here we have our 3, and we're going to multiply it by 1 over the natural log of our base, which is 2, times our x. Let's see, and then from that we're going to subtract 3 log base 2 of x times derivative of the denominator, which is 1, divided by the denominator squared, which is x squared. Cleaning this up, we have x times 3, or 3x, over x natural logs of 2, minus 3 log base 2 of x, all over x squared. If you want, you can find a common denominator. You can play around with this as much as you want. It's probably going to be, again, a problem where you have to find the equation of a tangent line, replacing your x's, so a lot of things will cancel. Find a common denominator, though, if you want. 3x, denominator here is going to be x natural logs of 2, so we have 3x minus 3x natural logs of 2 log base 2 of x. And that's all over x squared over 1, so we can multiply that by 1 over x squared. So nice, clean, if you call it clean. is 3x minus 3x natural logs of 2 log base 2 of x over x to the third natural logs of 2. Which I suppose then we could actually clean this up a little more, couldn't we? We pull 3x out. So we get 1 minus the natural log of 2 log base 2 of x over x to the third natural logs of 2. And an x will cancel. Yay! Something actually did clean up, didn't it? So we get 3, 1 minus the natural log of 2 log base 2 of x over x squared natural logs of 2. And that would be a nice, beautiful multiple choice answer, wouldn't it? I guess I will preference this section. Not a major problem or a set of problems that are going to come from this for the AP exam, but it's something that you should be able to muster your way through, especially with just a little bit of review. Good luck!